That would be, what is the value of any computer system if we cannot trust it? And here I'm not just talking about the computer's ability to perform the tasks that we require from it, but more that the information that we generate and access through that computer is safe. If we cannot trust our systems, then we might as well take any serious business decision that we're making inside our company or quote that we're doing to a potential large customer or tender and publish it directly on our website. People are stealing money every day. You shouldn't kid yourself about this. I know that there's an English author who recently published a book called Dark Knight, who basically went undercover in the British IT criminal world for about half a year, exploiting everything that takes place. And it's big. We're talking about 250 million euros of revenue going through IT criminals every year. So the next thing, how do we really know that we can trust our computers? How can I actually know that I'm safe? So we have to rely on software to tell it to us, anti-malware solutions that we can install onto the systems, and hopefully they will be able to identify and remove any malware that attacks my system. The interesting thing about malware is that there's different levels of it. I talked to a guy once and said, so have you ever been infected? And he said, no, never. Because he was kind of expecting some small Pac-Man showing up on his screen and eating all his data, his icons, or, you know, people are looking for abnormalities inside their systems. But the problem is that the really cool malware is designed to operate under the radar in stealth mode. They will do anything to hide their own existence, so you cannot detect them by human eyes. There will be no abnormalities. They will not steal up all the CPU resources or create small Pac-Mans or small pop-ups saying, ha ha ha, hijack your system. So when we look at anti-malware solutions, it's so important that we choose a solution that is actually good. And I need to find the right button here. Here we go. Every time someone from the security company walks up to a presentation, they always have something like this, you know, some kind of schematics that puts them on top. And that's pretty easy because all of us can just hire some analyst company, have them do some testing, and if we pass them enough money, they'll make sure that we end up where we want to be. So these are kind of ridiculous. The same thing with me. Bitdefender creates the best technologies in the world to identify and remove malware. Don't trust me, I'm a sales guy. I'm supposed to tell you anything I have to in order to make you purchase my products. But there are some sources that we should test, and those are the independent test centers. There's a couple around the world. The way they work, like for instance this one, AV Test, is the biggest in Europe. They're German-based, so it's the bad guys, or the ones that used to be, but they make a really good effort of doing this. And we cannot bribe them to change their results. They are totally independent. The interesting thing about Bitdefender is that most people, when I ask them, so have you heard about Bitdefender? And they say, Bit the what? And the reason for that is our company has existed since 2001, but we operate in creating technologies. We have more than 100 manufacturers of hardware and software that embed our technologies, our engines, inside their products. Through them, more than 400 million users worldwide are protected through our technology. We're responsible for detecting and creating signature files for more than 70% of all malware detected on the internet. So when we look at this independent test and just take the top 5, well, obviously Bitdefender is on top, but these 3 products uses Bitdefender technology as well. So out of top 5, there's Bitdefender technology in 4 of them. So most companies, when they talk about security, it's, you know, it's not the price of it, because the expense of exchanging one security solution with another one surpasses the price of the software 100, maybe 1,000 times. So we need some really good value propositions in order to make people want to move from one security solution to another one, because most people have the faulty comprehension that they're all the same. So let's talk about malware, or the anti-malware client. I think most people comprehend it as a kind of necessary evil. We've all tried sitting with this brand new computer that we just purchased, and we end up to the point where we have to install anti-malware on it. And once it reboots again, this previously agile system is now something that resembles a slow donkey. So when we make the transition from traditional computing into virtualization, this becomes a lot more evident. The reason why we're virtualizing, well, this is what's it called then? I'm Danish, I'm sorry. I'm looking for this word when you do survey. This was a survey done by Enterprise Strategy Group in 2010, where they basically went out, it's American-based, and they went out to companies and saying, so why do you want to virtualize? Or if you've just virtualized, what were your success metrics? And the interesting thing here is that we look at the top, I'm supposed to have a button here, the top two ones is that, first of all, of course, obviously it's about utilizing the resource potential. Hardware today is so powerful that just installing a single server on it makes no sense when we have the ability to run more. Furthermore, it's about operational costs, more specifically to reduce them. We have so many amazing features inside virtualization that can help us run our RT at a lower cost. Here I'm talking about high availability, the possibilities to do snapshots before we make any serious alterations to the systems, so we can easily revert and come up and run again. But traditional anti-malware is ruining these success metrics. Here we go. First of all, we have a client on each virtual machine. This client will take up a lot of memory. We all know that. You can just open your own laptop and have a look. It takes up a lot of disk space, and when we start scaling that up, it becomes quite a lot. And when we talk about storage inside a virtualized environment, it's usually some expensive storage. We cannot run a virtualized environment off SATA disks. Well, you can try, but it's not going to be good. So this is quite expensive. So that leaves a lot of potential available resources that if we didn't run anti-malware, we would be able to run more virtual machines on the same hardware. The next problem is that an anti-malware client is basically designed to do the same task at the exact same time. They're all talking to some kind of mothership, and the mothership will say, hey, I've got an update for you. And they will immediately start downloading the update, they will install it, and at this time they are all sucking resources from the hosts. And that ruins the whole purpose of virtualization, because we're counting on each individual machine not requesting resources at the exact same time. So if people try to do virtualization with their desktops, for instance, and build a scenario like this, let's just keep a small scale, a couple of hundred machines, they will soon realize that once they put in an anti-malware client, it's going to slow everything down, and they go, I can't run with this. I've seen samples of customers who's basically taken out the anti-malware client, just crossing their fingers and hoping that they're not going to be infected. When they start scanning at the same time, several things inside an anti-malware client can request them to start scanning at the exact same time. We have other problems. If we'll get a lot of reads and writes, I/O activity on the storage. When that happens, it's going to ruin the whole installation. And this phenomenon is so known now that the guys who works with this come up with an expression for it, and it's called an AV storm. Another problem with virtualization is that, well, seriously, this security breach has always existed. When you start up an operating system, we all know that the network card becomes responsive quite fast. Then eventually the entire operating system is up and running. The kernel is up pretty fast, but the rest of it takes a while. And then finally, as the anti-malware is something installed inside the operating system, depending on it, is one of the last things that starts up. So that gives us a gap from boot, in boot time, where we can actually attack this machine, and there will be nothing to prevent us from getting in. The same thing happens reversed when we're shutting down the machine. The anti-malware client will close down as one of the first things, while the kernel is still active, and so is the network card, which presents us with an opportunity to attack it. The next thing is, like we talked about, or I mentioned previously, is one of the great things with virtualization is the snapshot and backup capabilities, which is amazing as an IT administrator to work with, because it gives us more ways of running a smooth installation. The problem is that once we use them, we're not just reverting the operating system and the applications, etc. We're also reverting the anti-malware client to the point where the snapshot of backup was taken. So when we revert a virtual machine, we're reverting the security state as well. This means we're not protected against the latest threats. Usually when we are reverting from snapshot or backup, it's because we had a problem. And there's stress, there's pressure on us to make the server or computer come back up so that we can put it into production. So when it finally boots, it's not updated, and the client goes, oh my god, I'm missing updates. So it's going to start downloading them and installing it. It's going to use a lot of resources on that. So even though we managed to put the machine back up from a snapshot, it's not fully operational yet, because it's going to use a lot of resources installing all the missing security updates. Yeah, I already talked about this. Of course, these machines, they're constantly receiving updates. Every single anti-malware client requires signatures. There's a local cache database and engines that constantly needs updates. And they're talking to the mothership, and when downloads occurs, we'll have a lot of impact on the network cards inside each virtual machine, and it's annoying. So what do people do to manage this? They'll go like, I'll sure that they only receive updates once a week or once a day, and we'll do it during lunchtime or something like that. Just to solve the problem. But is that security? No. I can tell you that in Bitdefender, we're the only manufacturer of anti-malware clients who releases updates hourly. Every hour, on the hour, around the clock, through the year, we release the latest signatures in order to provide our customers with the highest level of security. So changing this to solve it inside a virtual machine ruins the point. The last thing, of course, is that there is no intelligent way of doing scanning inside a virtual environment with a client inside each virtual machine. They'll be scanning the exact same things. Let's take a very simple example. So a lot of people use Google to find what they're looking for on the internet, and Google is funny because they change out their logos from time to time. So through this machine, we access Google. They just swapped out the logo, and we're downloading the logo. It ends up on the temporary internet files, or, well, regardless of what favorite browser we're using, and immediately it's getting scanned. A second later, another virtual machine access Google again, and the same goddamn image is going to be scanned again. We all know this, but this time it's the same CPU who's doing the work. That's silly. If you, the next thing is the administrative consoles in anti-malware solutions. They basically work the same way, all of them, and it presents a couple of problems with when we do virtualization, especially when you consider going to virtualizing your desktops, VDIs. The typical approach to creating a very good VDI implementation is to use templates. So we'll have a template for the marketing division, we'll have a template for sales, we'll have a template for finances, etc., containing the specific applications they require in order to do their business. So every time they log on, using bring your own device or whatever you implement in that specific organization, we'll spin up a virtual machine based on the template the specific user requires. all their personal stuff. We'll use roaming profiles for that. So eventually when the user logs off, we'll just kill off the machine. That way we can run a lot of virtual machines on a very small installation. Makes sense, especially because of a lot of licensing solutions where we can talk about concurrent running machines, so we can save money by doing it so. But imagine a traditional anti-malware console. If new machines are constantly being spun up every day, they don't have a security profile policy. So we have to go to the security console and assign one to them. And at the end of the day, when they log off, the machine is going to disappear. It will never exist again. So we'll end up with a lot of non-existing machines in our overview or our management, so that will ruin our overview of the security state. So when eventually everybody has a boss, when the boss comes, taps our shoulder and says, so what is security status here? Are we updated? Are we safe? Then it's going to be a nightmare presenting him with a really good report. So let's talk about how to solve this. Bitdefender created this amazing new solution of doing security inside a virtualized environment that we released 17th of November last year. And this is a whole new approach on how to do security, and it's designed for the virtualized environment. We know all the problematic areas, so we knew what was expected from us to create a solution for it. Here we are not talking about an anti-malware solution that we have to install on top of an operating system. We are not talking about a console that we have to install with an underlying database, etc., where it's going to take us days just to prepare the solution before we can start pushing it out. This is based on appliances. So boxes created in assembly that you can import into your favorite hypervisor, and they're built from scratch to do specifically what we require from them. Not relying on any third-party software like Tomcat for web servers or Java. I think you all heard what happened with Java lately with that big security breach. So with this solution, as we take security seriously, it's our own software from end to end. The whole idea here is to have a single appliance inside your virtualized environment where we can centralize all the scanning, all the security. So no software will be needed to do that inside each virtual machine. It takes a very short while to set it up, and it is designed to provide the high level of security. There's a lot of manufacturers of anti-malware. Most of their solutions are based on signatures, receiving signatures once a day, and then perhaps a thing like intrusion prevention. Intrusion prevention is also signature-based. It looks for patterns on processes. So it will identify a specific process that has already been identifying as having a malicious behavior. But creating your security exclusively on signature is not good enough. What about the latest threats? That's what we were, zero-day attacks, as we call it. And secondly, and more importantly, coming back to what I said previously, the IT criminals, this business is growing. So a couple of years back, it was the Soviet against us, and they were doing counter-espionage, and we had to get to that level before things like that occurred. But today, it's going to take me about 10 minutes on the internet to find some guy in Russia and pay him $800 to get into my closest competitor's network and obtain the information that I need. It's that easy and it's that cheap. This guy, he will not create a piece of malware that has been presented loads of places and eventually a signature has been based on it. He will attack a specific organization directly. So if your entire security is based on signatures, there will be no signatures for this specific malware. It's an open field. That's why this business is booming. Unfortunately, it's scaringly easy. So in order to protect an operating system, we need to look, of course, at all the files that are being generated on access. We have to scan them and see if there's something malicious inside them. We also need to look at the memory inside an operating system. Remember that all network packages that goes into an operating system resides inside memory. And we've seen a lot of malware now that will never create a file. They will live inside memory. It makes no sense on a desktop or a laptop that gets started and closed all the time, because when we shut down the machine, the memory is erased. But for servers, they run some of them for days, some of them for years. Did you hear that? For years. Before they're actually getting rebooted, so there'll be loads of time to do all your bad behavior. So we need to look at the memory. We also need to look at the registry. If something changes the registry, it can prevent the anti-malware from start up, or it can do things that automatically starts up without us knowing it. So we need to look at that as well. And finally, we need to look at the processes. The reason why Bitdefender is the greatest company in the world to provide security, the ability to identify and remove malware, is because of our heuristic mechanisms. We have several technologies. The coolest one is called Behave. It's a patented technology. So every time you start up a process inside your machine, we have the world record of creating the smallest kernel ever made. It's just 1.44 megs. So we take this process and we start it up inside this contained kernel, and we look to see what takes place. And if something weird is going on, it could be several things. It's trying to address ports that looks funny, or will try to duplicate itself, or do a network scan, or anything like that, we'll block it immediately. But again, the guys who create malware are getting cleverer and cleverer. So a lot of them are designing their malware to start up and lay dormant for a while before it starts doing its nasty business. So even if we release a process to the operating system, we'll maintain a watch on it to see what happens. And if it starts doing funny stuff, again, we block it. So this is the kind of technology that we're still able to provide from a centralized point of view. So the way this works is we have two versions of this. We have one specifically made for VMware. VMware has this vCenter solution that provides us with the ability to see the entire environment. When we talk about the other hypervisor solutions, Hyper-V, SendServer, what am I lacking here? Red Hat just came out with Rev, which is looking pretty good. They're a couple of years behind VMware, so they don't have these great administrative solutions yet. This is the design for VMware. And basically we start off with a console. But again, you don't have to install it. It's an appliance, you import it, you configure what data store to put it on, pass on some virtual CPUs and memory, and then you configure it with a static IP address, and then you start it up, go to the IP address that you configured with your favorite browser, and you're basically ready to go. The security console is the only one that's talking to the Bitdefender cloud. So we have a single entity that will look for updates, new things that it needs to do, download them and keep them ready to pass them on to the next. Then we need the engine. Let me just point here. It's what we call the SVA, Security Virtual Appliance. Theoretically, we can have a single appliance managing security on virtual machines spread on several hosts. That's within the design. But we have to realize, if we consider scaling this up, if I have another host here, then the scanning process would have to go out on the physical network. That's not a problem, but it would require a larger physical network in order to gain the same kind of performance. So we recommend deploying an engine per host. So the hosts, yes, and here we have a couple of virtual machines. This solution will protect any kind of virtualized operating system. So this is not only for Windows. We could do the same on all the big Linux builds, Solaris even, where we can protect them. And then, as I said earlier, we don't need any software inside each virtual machine. That's accurate, but still not, because we need something to open up a door. Our entire technology here is based on that we found a way to open up a door. It's a small piece of software that we install onto each virtual machine. I'll get back to more about this specific component. But basically, it opens up a gateway, allowing the centralized engine to access each virtual machine, from where we can look at all the areas I talked about earlier: memory, files, registry, and the running processes. For the other hypervisors out there that is not VMware, the only difference is that we don't have this vSensor component to plug into. Obviously, when Microsoft eventually creates one, and I know that Citrix will as well, we'll create a solution to plug in so we can see the entire environment. The connections here is just TCP/IP based. That's it. We have a specific set of ports. So if you even want to add further security to this, running software-based firewalls, then you can define specifically what ports and from where the source is allowed to use them. The interesting thing is that when we centralize on each host the scanning process, that means that we can now start scanning intelligently. So we've implemented multi-level caching onto the mechanism. So going back to the Google example I gave previously, in our scenario, it's only going to be scanned once. The first virtual machine that accesses a unique file or starts up a unique process, we're going to scan it. If it's safe, we're going to cache the header or the hash code, if you like, of these components. So when the next virtual machines access the exact same process or file, we're going to check the cache first. If it's there and if it's safe, we're not going to scan it. You can imagine what kind of impact that has on the CPU down on the host, and furthermore, the I/O activity on the storage. It's going to be reduced a lot. Of course, if the files or if the process gets modified in some way, we will have to scan them again. But here we're only scanning the changes. It's the same as the technology used behind Delta backup. And that means that we don't, big file. Let me ask you guys, you don't have to answer because there's a lot of you here, but I'll just pose an open question that you don't have to answer. When was the last time you did a full scan on your file servers? So I'll reply for you, never. Why? Because we can't do it. Doesn't matter. If you have a file server, let's just say you have a terabyte of data or half a terabyte of data. So we want to do a full scan. Can we do it during working hours? No, because it will be unresponsive. We can't do it at 8 o'clock because modern people are working all the time. They get frustrated if we want to create a hole at 10 o'clock at night. So we'll have to wait until past midnight. So we'll start a full scan. And at 6 o'clock in the morning where we have to stop it because now people are going to work, we're 3% in. Damn it. I'll just resume tomorrow. The problem is when we resume tomorrow, it's going to start from scratch. So the whole caching mechanism and the Delta backup of rescanning files that have changed itself actually presents the ability to chew through any amount of data and removing any malicious things hiding inside them. The small piece of software that we need to put into each virtual machine is just 14.5 megs of disk space. Remember that traditional anti-malware clients is somewhere between 170 to 300 megs. The 14.5 megs it's a static application. It will not grow. There are no signatures inside. There are no cache databases. There are no engines. Basically, we have two components. There's the gateway, and then we have an optional user interface. We do not install this piece of software. We basically copied it in, and then we delete it out. And then we make two alterations to the registry. One, providing the ability to remove the agent through uninstall capabilities. The second one, registering the gateway as a service, so we assure it starts up simultaneously with the virtual machine. When it runs, it takes up no less than 2 megs of memory. It will never take more than that. Where again, traditional malware, that can be several hundred megs of memory. And it provides the door, allowing the centralized engine to access. The second component is a user interface, and it's optional. So meaning, when we create the security policy, we can define inside it if we want to use this GUI or not. Let's say that the specific virtual machine is a part of a SQL cluster. Well, we all know that it's only going to be the SQL guys who ever are allowed to access the desktop directly. And they don't need a user interface. They already know it will be protected by something else outside the system. They also know where to look if something weird is going on. But if we have a virtual machine that's being accessed by normal users, That could be a virtualized terminal server, Citrix or Microsoft, or a VDI, virtualized desktop. Then we need to have a method of informing them about security measurements that takes place onto their system. Imagine a secretary who's been working for a week on an 80-page long Word document that her boss needs for a meeting tomorrow, and while she's working on it, it gets infected. It cannot be disinfected, so it's moved to quarantine. For her, the document disappears. I do not want to be sitting on the other end of that support call when she calls. She will be very frustrated and agitated. So we have the ability to show them, just as they're used to, if something takes place onto their system. In order to deploy it, that's pretty simple. If we talk about Microsoft, then we can use group policy, of course. You can download the small agent, a piece of software, create a group policy, ensuring that it automatically gets installed to any machine that belongs to the domain. We also have the ability to deploy it from our console, and basically we just need to know the IP address of each machine, or scope, and then we need credentials. And you can assign as many credentials as you like. So if you have several domains or work groups, then you can just configure as many credentials as you like and then deploy in one go. Before talking about, I remembered something before that I want to tell you. This technology where we access each virtual machine, I can do a blackout here, I think. There we go. Normally when we have to exchange one security solution with another one, it's a nightmare to plan, because we have to uninstall the existing one first, then we have to reboot, then we have to install the new one. That usually requires another reboot, and then we're done. But all these reboots, we know that we have no security during this period of time, and 2 reboots during working hours, it's very difficult to plan, especially when we're talking about larger networks. Because we're accessing from the outside, and we don't have these components like this big octopusy with its tentacles, and you saw this picture I was using earlier, we can actually coexist with traditional malware. So with this kind of technology, we can implement it on an existing solution with traditional anti-malware clients inside each virtual machine, and they can coexist. That's great, because as soon as this is on, then eventually we can uninstall whatever was there. Furthermore, we did something else. I've been monitoring Microsoft KB articles for a couple of years with their recommendations of exclusions for their servers and their server applications. And a couple of years back, it was like 8, so it was pretty simple. But today, there are 72. So there's quite a lot. In our engine, the guys were so clever that we have pre-taught our systems to know of all these KB articles. So that means you can deploy our scenario here on an Exchange server without making exceptions for the Exchange processes of the mail store. You can put it on a SQL server without doing exclusions for MDF, LDF files. You can put it on a domain controller without making exclusions for sysvols, or else your replication is going to mess up. So it's extremely simple to put on. The security console that we have is also, like I said previously, it's just an appliance. So it takes 5 minutes once you've downloaded and you're ready to go. It will hook up to all the engines, so you can deploy more engines inside each virtual machine, but it has several other capabilities. It has the ability to hook up to Active Directory. That's interesting if you're running Hyper-V or anything like that, because with Active Directory, and if you've planned your structure good, then we can actually see what the virtual environment looks like. Furthermore, as I named previously, we can integrate with the VMware vCenter. And that is interesting in relation to the nightmare I talked about previously with the management console and VDIs. Because if we can see the hypervisor, then we can assign security policies to resource groups rather than individual virtual machines. So if I want to run 20 or 200 VDIs, I'll create a resource pool consisting of several virtual CPUs, memory, and then I'll spin off all my virtual machines off these. A single policy pointing into it, while now the problem is solved. When we made this solution, of course, then we said, well, we got the questions almost a year ago saying, but what about the rest? Yes, I have a virtualized environment, but I also have a lot of traditional solutions. I have 100 workstations out here. What about that? I'm not fond of having just a single console. I would like to have just a single console to manage everything. So with this security solution of the console, we can plug into all our traditional on-premise solutions. So you can watch and monitor and manage Windows, Linux, Unix, servers, mail server solutions, SQL, SharePoint, Mac, whatever. Or Android and iOS, of course. So to make I know I'll have like 8 minutes left. Yeah, I think so. The reason for doing this, there are several. So here we actually have some value propositions. It's not only about solving the problems that is related to running security inside the virtual environment, but it's about giving you back the resources that you currently have to spend on anti-malware. And it's quite a lot. This is not marketing. This is actual truth. We have extensive testing. We use a product called VSI Login. And we're putting a joint white paper out with them in about a week from now, proving that all our test results are accurate. So regardless, this is just an example here of a specific, I think we're running like 72 virtual machines off 8 hosts or something like that, but that's not the point. It's the same numbers. But by centralizing the scanning mechanisms and the multi-cache technology, we can reduce CPU consumption with 30%. The memory needed for our centralized engines, plus the 2 megs of memory for our gateways, compared to traditional anti-malwares, will save you 10% memory. The last thing is, yeah, we have a button here. There we go. The I/O activity, I cannot give you a number of that because it varies a lot. There's a big difference between having a virtualized Exchange server that receives 40,000 emails every 10 minutes compared to 2 file servers that are being used by 60 people. But you can imagine the whole technology I talked about will reduce I/O activity a lot. Any questions?